Hello, everyone. Well, it's a full room, so thanks for being here. I know there are lots of great sessions here today, and I'm glad that you came here. So my name is Mete Atamel. I'm a developer advocate at Google. I'm based in London, and today I'm going to talk about microservices and Kubernetes. Before I start my talk, I have a clicker. So this is my Twitter, my email, my blog. Feel free to send me any questions that you have after today. I would love to answer your questions on Kubernetes, on Google Cloud, or anything cloud related, really. I also have a feedback link for my talk. I always like to make my talks better, so if you have time, it just takes a minute after the talk. Feel free to send me your feedback at this link. And I'm going to have these links at the end of my talk as well. Also, I'm going to tweet after this talk my slides, so you don't have to take pictures of the slides if you don't want to. But feel free, okay? So what are we going to talk about today? I always start my talks with why, what, and then how. So why you should even care about containers, why you should even care about Kubernetes. So that's what I'm going to cover in the first half of the talk. And then I'm going to talk about what. So what is Kubernetes? What does it actually provide to you? So the building blocks of Kubernetes. And then finally, well, not finally, but throughout my talk, I'm going to show you how. So I'm going to show you some demos and some code samples on how things work with Kubernetes. So that's kind of like the agenda. So before I talk about containers and Kubernetes, I just want to briefly talk about microservices, because that's kind of like the motivation for most of the containers and Kubernetes kind of topics. So let's talk about them. Let's talk about the monolith first. I'm sure you heard about this a lot, because in every conference you go to nowadays, there's a talk on monolith, breaking it down to microservices, stuff like that. But let's just cover it quickly so that we can talk about containers. So what is the monolith? Depending on who you talk to, you get different definitions. But in my mind, a monolith kind of looks like this. They're a very simplified model. So there are a few modules. They have some kind of dependencies on each other. They're calling each other directly. And they have a shared backend. It's either a database or a NoSQL database or something like that. And then the key thing with the monolith is that even though you work on your module, you try to make everything modular and separate from each other, they're all bundled together and deployed all at the same time to an app server or a web server or something like that, right? So if you are from the Java world, your modules would be your web applications that are bundled into WAR files. So even though you could deploy WAR files separately, we didn't do that in Java. What we did is we created something called enterprise application. So we bundled all the WAR files into an EAR file, and then we deployed this EAR file to the app server. So obviously this has lots of problems. You have unnecessary coupling. You can only update everything all at once, or you don't update anything. You cannot scale individual pieces independently. You don't have ownership for the whole system. So like you can have ownership for the module itself, like maybe each team owns the module, but then who owns the whole system? I worked in places where each team was really good at maintaining their own module, but then when things broke because of the integration between modules, everyone pointed fingers to each other. So it doesn't really work. And it becomes really difficult to debug and test. Again, in this one place I worked at, I could work on my module by myself, but then if I had to test the whole thing wouldn't start on my laptop because it was too big. So I couldn't debug the whole thing, and it was a nightmare to figure out what's wrong. And there are probably more problems, but you see the theme here. There's like you don't want to do the monoliths anymore, and that's what we've been doing in the last few years. We are basically trying to break the monolith into microservices. So what are microservices? Again, depending on who you talk to, you get different answers. But in my mind, it has like 2 or 3 characteristics. First, you have a service that does one thing really well, or maybe not one thing, but a small number of things really well. So you don't have a service that tries to do everything all at once. It is an independent service that tries to tackle a small domain by itself. So that's number one. The second thing is it has its own data store. So it doesn't depend on a global data store that you share with other microservices. Because you can make your modules, you can modularize your application all you want, but if you're depending on a single data store in the backend, that means that you have dependencies, so it doesn't work. So it has it's small, it has its own data store or database, and then it defines a public API for other microservices to call. So microservices that don't call each other directly, they go through the public APIs. And this is important because when you have public APIs between microservices, the contract is much more explicit. So you know who's calling you, you know what API they're calling you, and then usually it's a good practice to version your APIs so that if you need to change anything in the microservice, you can change it. But then if you need to change the public API, you can create a new version and then let people call that while the old stuff still works. Okay? So you can have a microservice that's calling another microservice. So you still have dependencies with microservices. It doesn't mean that they're independent and they don't work with each other. They still work with each other, but they're going through the public APIs, and that's the key. And then maybe this guy is calling another microservice, and then your application is not bundled together. So you don't deploy microservices all at once. You deploy them independently. Some of them, maybe they're living in the same machine, but some of them, maybe they're living in different machines. So your application is more logical now. It's not an EAR file as in the Java world. It's more like a combination of microservices that are deployed in some places, and then the combination of that is your application, okay? So microservices, they solve a lot of problems of the monolith, and that's good, but it also introduces new problems. So now, instead of worrying about one thing, you need to worry about these multiple independent systems, and that can be challenging. Debugging and testing can still be hard, because debugging a single microservice might be easy enough because you can do it on your laptop probably. But usually when a request comes in from the client, it goes through one microservice, and then that microservice calls another microservice, and that calls another microservice. So if you don't have proper logging and proper IDs for your requests, it can be really difficult to figure out what's wrong where. So you need to make sure that you have instrumentation. You need to make sure that you have logging enabled so that you can trace things properly across microservices. You know, we have this infamous problem called "it works on my machine." You know, you run something on your laptop, it works great. You put it in production, it doesn't work, and you don't know why. Well, actually, you know why, because the environment here is different than the environment in the production. No matter how hard you try to replicate the same environment, it's never the same. So microservices doesn't help with that. You know, you still have the same problem of, you know, it doesn't work. My microservice works great on my machine, but it doesn't work in the cloud. And then you have these problems, I call them production problems. They still apply. So if you want your microservices to be redundant, you need to make sure that you have multiple microservices running. If you want them to be resilient, you need to make sure that your microservices has a health check, and then someone is checking that microservice once in a while. And if the microservice is down, you need to create a new one somewhere else and get it up and running. If you want to upgrade your code, you need to do that in a rolling upgrade fashion that I'm going to show later. And if something goes wrong in that upgrade, you need to downgrade it in a consistent way. And if you need to scale different parts up because you have lots of load coming to the front end, you need to do that. If the load goes away, you need to scale down to save costs. So all of these problems are still your problems. Someone has to solve them. So just because you took your monolith application and broke it down into microservices doesn't mean that you don't have these problems anymore. You still have them, and you probably have them much more because you have multiple microservices to deal with. So they're even bigger problems now. So in this demo, by the way, I made videos on my demos because I wasn't sure how the Wi-Fi was. First, I'm going to build a simple microservice in ASP.NET Core. And the reason why I'm doing that is because, first of all, it still boggles my mind that you can run ASP.NET on Linux, and it actually works. So I'm just going to create a simple ASP.NET app, and just take a look at it. And then later, we're going to take that app and containerize it, and then we're going to deploy to Kubernetes. So let's take a look. So let me just pause here for a second and make this full screen. So what am I going to show you here is that this is Google Cloud Platform console. Yeah, okay, great. And then in this console, there's something called Cloud Shell. Cloud Shell, it's basically a shell, a Linux box in the cloud that you can connect from your browser. It makes development and demos much easier because you are running everything from the browser. So I'm going to use Cloud Shell to create an ASP.NET Core application. So let's just start. So here, I'm in the console. I'm creating the Cloud Shell. This gives me a VM somewhere in the cloud. It takes a few seconds to get a VM, so I'm here. Sorry for the resolution. It's not that great. I'll try to explain it to you. So you basically have your own home directory. And what I'm doing right now is I'm going to I'm looking at .NET. This is the command line tool where you create .NET Core applications. It's already installed in Cloud Shell by default. So what I'm going to do is I'm going to do .NET. First, I'm going to create a folder for my application. I'm going to call it Hello World ASP.NET Core. And then I'll cd into that. And then I'm going to create a Hello World.NET application. So I'll just say .NET new -t web. So this says create a web Hello World application for me. This is something that comes with .NET Core. It already created a bunch of files for me. And what I'm going to do is I'm going to look at the program.cs file. This is the main file for .NET applications. And it creates a pipeline. And in that pipeline, I want to make sure that my application starts on port 8080. So I'm just going to add use URLs and then HTTP localhost port 8080. So this will make sure that my application, when it starts, it will start on port 8080. That way I can look at it from the browser. So I'm just going to save that. And then what you need to do is you need to do .NET restore. So this restores the dependencies for your application. So it looks at project.json that has some NuGet dependencies, and it will get those dependencies and install them here. So this will take a little bit. And then once we have the dependencies, we can just do .NET run and run the app, and then take a look at it in the browser. There's nothing fancy here, just a simple Hello World application. But then we'll use this app to containerize it and then to deploy to Docker. So it will make things clear later. So we are doing .NET run. So this is compiling the application and then running it in this Linux box. Yeah, it's running on port 8080. So this is ASP.NET on Linux. So I can't believe that I'm saying this. Like if 3-4 years ago, you couldn't think about this, but now it works, so it's great. So this is the app, and it's just a simple page with some slider and stuff like that. Nothing fancy, but we'll use this app later, okay? Now, all right. Now let's talk about containers. So what is a container? Again, depending on who you talk to, you get different definitions of what a container is. But in a single sentence, I think a container is a lightweight way of virtualizing applications. Now at this point, you might ask, like we already have a way to virtualize operating systems, right? We have virtual machines. So how is this different? I think the key here is this lightweight key. So virtual machines, like operating systems, they're virtualized, but they're really heavy. Containers give us a much lighter way of virtualizing our applications. They are basically Linux processes. They started with Linux, but now Windows also supports containers, so you can have Windows containers as well. They are lightweight. They are sealed and isolated, so you can run multiple containers in a single OS without them stepping on each other because they don't share namespaces. They're really easy to deploy, and they're really easy to introspect, so you can actually log into the container, look at the container, look at the logs, and see how things are working there. And I guess one of the key things of containers is that they're composable. So you can actually have a base image that you can depend on, and you can build your image on top of that. So what this enables you to do is you can basically layer your dependencies on top of each other, and that really helps for your dependencies. The main container platform is, as everyone knows, is Docker, but there are others like Rocket, and I'm sure there will be more in the future. And I guess why containers is, so this is what we used to have. We used to have shared machines where we installed the operating system kernel. On top of that, we had libraries, and then on top of that, we had our applications. The problem in this case was that there was no isolation whatsoever between your apps. They were all sharing the same kernel. They were all sharing the same libraries, and you had this high coupling between apps and your actual environment. Now, after shared machines, we had VMs, virtual machines, that came along. So in virtual machines, on the same physical machine, you basically run multiple operating systems virtualized. So in this case, your kernel, your libraries for the app is in the virtual machine. So there's isolation. But then this was really heavy, because now instead of having one kernel, you have to maintain 4 kernels, and just trying to do this in your development environment wasn't feasible. You wouldn't have like 5-6 virtual machines on a single laptop and develop and deploy with that. So with containers, what you have is you share the single kernel, so you don't have multiple kernels anymore. but you put the libraries and the application in the container itself. So what this enables you to do is you basically have the isolation that you need, but you don't have the heavyweight kernels in the virtual machines. So you don't have 4 kernels, you just have 1 kernel. So this way you have the best of the both worlds. So you have isolation that you don't have here, but it's not as heavyweight as having multiple virtual machines. So that's why containers are great for development and also deployment. And then containers we've been using containers at Google for a long time, for like 12 years or so. And everything at Google runs in containers. So Gmail, web search, even Google Cloud Platform virtual machines, they run within containers because we like what containers provide. And our whole infrastructure is based on containers. And I think this number is probably outdated by now, but this is this kind of scale that we do. Like we launch over 2 billion containers per week. All right, so let's now look at our simple microservice that we created and try to containerize it into Docker and see how that works. All right, so here I am again in my Cloud Shell, and then I have my, I don't know why it keeps doing that. All right, so first what I did right now is I did .NET publish C release. So I'm basically publishing my application. What that does is it looks at my application, looks at all of its dependencies, and it creates a single DLL that it basically bundles everything into a single DLL. And I'm going to use that DLL so that from Docker. So Docker will call that DLL. So I'm basically getting all my dependencies together for Docker to use. So in the end of this, we'll have a single DLL that Docker can call. Now what you do with Docker is that first you need to create a Docker image. So the image kind of defines how the container will run. So to define the image, we need to create what's called a Docker file. So the next step will be to create a Docker file that will define our image. So what I'm doing is I'm going to the release folder where the DLL is published, and then I'm going to create a Docker file. So I already actually have a Docker file, so I'm just going to copy that Docker file from outside to my published folder. And let's just take a look at the Docker file, see how it looks like. So I'll just pause this for a second. All right, so what this says is, it's very hard to see actually. Let me move this. Yeah, I think that's a little bit better. So what this says is from Microsoft.NET 101 runtime. So this is the image that we are basing our image on. Remember I told you that in Docker you can have images, you can compose images. So I'm actually composing my image on top of Microsoft image. So this gives me the Docker runtime, Docker.NET runtime, .NET core runtime from Microsoft. And then I'm just copying my directory that I'm here, which is the published directory, to app folder within the container. Then I'm setting my working directory to the app folder. And then I'm exposing port 8080 because that's where my app runs. And then I'm setting an environment variable called ASP.NET Core URLs. This makes sure that my ASP.NET Core application starts on port 8080. And then entry point is basically what happens when Docker runs. So this is what will get run. So here I'm setting the environment, and here I'm actually defining what's going to happen. So I'm just saying .NET hello world ASP.NET Core DLL. So it will basically just call my DLL. So that's it for the Docker image. So this will create from this image we're going to create a container that will run our application. So let's keep going. All right, so what we need to do is first we need to build our image. So we're going to say Docker build. And then it's usually a best practice to tag your images. So here I'm tagging with GCR.io. That stands for Google Container Repository, because I'm going to push this image to Google Cloud. So that's why I'm tagging it this way. So this says Google Cloud Repository. This is my project ID, and this is the name of my image with version. So what will happen is that now this Docker build will look at the Docker file, and then from there, the first thing it's trying to do is pulling the image from Microsoft, because it depends on the Microsoft runtime image, right? So it's pulling that, and then after it pulls that image that I depend on, it will do the other steps that I specified. So it will basically copy my app to the app folder. it will, and then eventually it will run .NET for me. So we'll just wait for this a little bit. Now this is step 1, so it's copying my app to the app folder in the container. Step 5, 6. So that's it. My container, my image is built, and now I can actually start a container. So what we're going to do is we're going to do Docker images. So if you look at the images, now I have 2 images. This is the image I built, and this is the image I depended on. So they're both downloaded on my machine. And now I can run my image. So what I can do is Docker run. -D means run in the background, so don't hold the console. -P means expose my port in the container to the port on this host. So the port 8080 on the container will be mapped to port 88 on my machine. Then I'm pointing to the image that I just created. And this started the image with this ID. And then if I do docker ps, I can see that my image is running. And then if I do a preview, I should see the same app running. Now, this is not too different than what we've seen before, but the big difference is that it's running within Docker container now. So what this means is that we can actually take this image and deploy it to anywhere Docker is running. So that's the key difference. And if I do Docker stop and provide the ID, I stop my image. And let me just pause for a second. So we built an image. From there, we create a container, and we ran it, make sure that it works. Now what I'm going to do is I'm going to push this image to Google Cloud. You can push this image to anywhere you want. You can push it to Docker Hub, anywhere. But the reason why I'm pushing it to Google Cloud is because I'm going to use Kubernetes in Google Cloud. So by pushing it to Google Cloud, I'm making sure that my image is available when I build my Kubernetes cluster. So what I'm going to do is I'm going to use something called gcloud. It's a command line tool that you can use to talk to Google Cloud. It's already installed here in Cloud Shell. And I'm just going to say Docker gcloud docker push, and then just point to my image. So what this will do is it will just basically look at the images I have on my machine, and it will push that to Google Cloud. We don't have to wait for this, but this will take like a couple of minutes, but I'll go back to my presentation. All right, so we took our microservice, we containerized it with Docker, and now we pushed it to Google Cloud Container Repository. So containers, what do they help for? Is basically they give you that context for your application to run. So the context that you have on your laptop and the context that you're going to run in production will be exactly the same. So that problem that we had before, where things run on your laptop but they don't run in production, that goes away with Docker. As long as you have Docker, it will run exactly the same way on your laptop and in production. But all the other problems that I talked about, resiliency, scaling up, deploying a new version and stuff like that, they're still your problems. So containers by themselves, they're not enough for these problems. So that's when Kubernetes comes into play. So Kubernetes basically tries to answer these questions. How do you provide resiliency? How do you scale up and down? Things like that, okay? So what is Kubernetes? It stands for, it's a Greek word. It stands for governor. By the way, everyone calls this Kubernetes, but actually it's Kubernetes. I know this because I'm from Cyprus, so I know a little bit of Greek. But since it's been Americanized and everyone calls it Kubernetes, I have to call it Kubernetes now. That's just something small for you to know. Basically, it manages container clusters. It came from something called Borg. So as I mentioned, Google Cloud, Google has been running containers for a long time. And we built a system called Borg that's been used today as well. It's an internal container management system. So the people who worked on Borg, they basically created Kubernetes and they open sourced it. It supports multiple clouds. So it supports Google Cloud, AWS, Azure. It can even run just on your laptop or any kind of machine, really. So that's the beauty of Kubernetes, is that you don't have to choose your cloud provider for it. And then it also supports multiple container runtime. So most people run it with Docker, but you can run it with Rocket as well. It doesn't really care. And it's 100% open source, and it's written in Go, okay? At the high level, this is how it looks like. So there's a master that kind of maintains the cluster. And then there are nodes where you actually schedule your containers. The nodes has something called kubelets. So kubelets basically, manage the communication between the master and the nodes. And then as a user, you use the API or the CLI command or the UI to talk to the master. So you usually just talk to the master. You don't really care about the nodes. You set up your cluster once, and then you let the master take care of the nodes. You don't actually, as a user, care about it too much. And as a user, basically, what you care about is the API, and that's what we're going to talk about next. You don't really care about the container, like you don't really care about even the master itself. You just talk to the API, and then from the API, you get all of the functionality. So setting up a Kubernetes cluster, it has 2 steps. First step is, first you need to set up your cluster. There are 2 things you can do here. You can take the easy way and use what's called Google Container Engine. So Google Container Engine, it's an engine where Kubernetes is already hosted. So you can use one single gcloud command and get a Kubernetes cluster with the number of nodes that you need. So with that, it's literally just running one command, and then you have your cluster ready. Or if you want to set up your own cluster, then you need to basically do all these steps. You need to choose your cloud, you need to choose your node OS, you need to provision machines, you need to configure networking, all that kind of stuff. There's documentation on it. I'm not going to go into details, but basically there's a lot of steps that you need to do yourself. You can do it if you want to. So if you are going with Google Container Engine, this is how it looks like. So you build your image, as I show you in the demo. Then you push that image to Google Container Registry. And then from there, you create a container cluster using Kubernetes. So you use gcloud to do that. And once you have your cluster with one command, you basically use kubectl. This is the command line tool for Kubernetes, and talk to your cluster. So this is the high level of how things look on Google Cloud if you want to run it in Google Cloud. So let me just show you quickly how to create a Kubernetes cluster. So here I'm in Cloud Shell again. I push my image, remember? And now let's take a look at the container registry and see that our image is there. So if you look at the container registry, there's a hello.net. And then under there's a v1. So that's the image that I just pushed from Cloud Shell to Google Container Registry. So that's good. Now what I'm going to do is I'm going to use the gcloud command and get a Kubernetes cluster. So what I'm saying here is gcloud container clusters create. And then I'm going to call my cluster hello.net cluster. And then I'm going to say number of nodes. So this is how many machines you want. In this case, I'm just saying 1, but you can say whatever you want. And then machine type, you can also specify the machine type you want. In this case, I'm using a standard machine, which has, I think, like 2 CPUs. And the definition is on Google Cloud. I don't remember. And then you can also specify the zone. So here, I'm making sure that my cluster is set up in Europe West 1. So this is all it takes, basically, to create and get a Kubernetes cluster. And if you go to Container Engine, when the cluster is ready, you're going to see it up here when it's created. So I'm just going to go fast forward because I don't have that much time. But I just want to show you what happens in the end. So when this comes up, as you can see, the cluster is starting up. So within like a minute or 2, you're going to have a cluster ready where you can run Kubernetes and deploy your pods, okay? All right, so we got our cluster. What's next? Next is basically using the cluster. So you basically run what's called pods. I'm going to talk about that shortly. ReplicaSets, services, volumes, all the stuff that Kubernetes provides, basically. Now you're ready to run against the cluster that you created. So let's talk about that. So this is actually the point of the talk. So what are the building blocks that's given to you by Kubernetes? First, this is what the Kubernetes cluster looks like at the high level. What you have is first, you have what's called a pod template. I'm going to talk about what a pod is shortly. But basically, this is the template that you want to schedule on the nodes. It comes from a registry. So in Google Cloud, this is a Google Container Registry. So from the pod, there's something called replication controller or replication sets. For example, in here, we're saying we want 3 replicas with this pod template, and we want to have these labels. So the replication controller basically makes sure that this gets created. So it basically schedules 3 pods on the nodes that you created with these labels. So the replication controller will make sure that that's the case. And then each pod has 1 or more containers. I'll talk about this in detail. And then once your pods are ready, you want to expose them to the outside world. So what you do is you create a service. So the service basically abstracts your pods away so that you can just talk to the service, and the service basically load balances it to the pods for you. So at the very high level, this is how it looks like. So now I want to get into details of every building blocks. First, I want to talk about deployments. So in Kubernetes, when you have a cluster, you create a deployment. That's kind of like the high-level construct that you create. And that deployment will create all the things under the covers. So it will create a replica set, it will create a pod, it will create all the things needed for the deployment. Yeah, so basically what I said, so deployment, you create a deployment that will create the pods and the replica sets, and we'll talk about the pods and replica sets in the next slides. So let me just show you how to create a deployment in Kubernetes. So here I am again. I have my cluster ready. Now what I want to do is I want to create a deployment so that I can deploy my container to that deployment. So first I need to authenticate with my Cloud Shell to the cluster. So that's what I need to run. So I run the gcloud command to authenticate. Now I can run kubectl commands against my cluster. So kubectl is the command line tool to manage Kubernetes. So what I'm saying here is kubectl run hello.net, and then I'm just pointing to the image. So basically I'm just saying create a hello.net deployment and use this image that I pushed before for this deployment. So this will create a deployment. It will create a pod that has that image container in it. It will expose port 8080, and then it will also create a replica set to make sure that my pod is running. And I'm going to talk about replica set next. So this created the deployment, and as you can see, it's really fast. And then if I do get pods, I have a pod running. So I have one pod. It says container creating because it's creating the pod right now. But if I do get pods again, now it says it's running. So within like seconds, the container is running. And then I can do get replica sets. So this is the guy that will make sure that my pod is running. That's also running as well. If I do get services, this is the guy that will expose my pod to the outside world. It has an internal IP, but it doesn't have an external IP yet because I haven't exposed it to the outside world yet. So deployment created all the basics for me by just running the command. And then we're going to look at the rest now. So we did the deployments. So let's talk about pods and volumes. So a pod in Kubernetes world is basically the smallest unit that you can schedule. Usually it has one container, but sometimes you need two containers to live together and to die together. So in that case, it can contain multiple containers. And it can also contain volumes, which are storage, internal storage for pods. So in this case, I have a file puller that pulls some files from somewhere, and it saves those files into a volume, and then this web server exposes those files to consumers. So the pod itself, it actually contains two containers. It also contains a volume. So the reason why I put them in a pod is because I want them to live together and to die together and to be scheduled together. So you can do that with pods. Volumes, I already talked about volumes. They're basically pod scope storage, and they're all different types of volumes that are supported. And yeah, that's it. So you have your pods. Now, once you have your pods, you can label these pods, and you can select them. And that's really important in Kubernetes. So what you can do is you can basically attach small key value pairs on top of the pods. So you can do, for example, in this case, we have 4 pods. They each have the label app, my app, so they all of them have it. They also have phase prod. Some of them have phase prod, and some of them have phase test. So maybe these are the production pods, and these are the test pods. And the role is FE. So these are the front-end pods, and these are the back-end pods. So you can attach all these labels to the pods. And then what you can do afterwards is that you can select them. So you can say, give me all the pods that are for my app. So it will select all the pods. Or you can say, give me all my pods for my app, but only the front-end ones. So it was like these. Or you can get the back-end ones like that, and you can get the production ones like that, and the test ones like that. So it gives you all these different ways of selecting your pods. Now, let's talk about replication. And I'm going a little bit fast because I don't have that much time, but I want to go through this quickly. So as I mentioned, like the pods are running, but someone has to make sure that these pods are actually running. And if the node that the pod is scheduled on goes down, someone has to make sure that a new pod is created, right? So that's what the replica set does. Replica set, in this case, we say, this is the name of the replica set, and this is the selector. So this is the selector for the pods, and then this is the template that I'm going to use to create pods. In this case, I want to make sure that I have 4 replicas, so I want to make sure that I have 4 pods. What it does is basically just keeps asking the API server, how many pods do I have? If I have 3, then it will create 1, and then make sure that we have 4. And then it will keep asking again, how many do I have? Is it 4? Then if it's 4, then it won't do anything. So basically, it will make sure that you have 4 pods running all the time. And in this case, for example, we have a replica set that has pods 3, that has the label app demo, and the other label is color, blue or gray. So if you look at the pods, we have 3 pods. They all have app demo, because that's what we want in the replica set. And then the color in these 2 cases is blue, and the other one is gray, because the color can be either. So the replica set basically makes sure that that's the case in your cluster. So let's look at the replica set quickly. So we created our deployments that created our pods and replica sets. So in this case, I have a pod that's running. And it's only 1 pod, because it's 1. And then if I delete the pod, now what will happen is that the replica set will detect that and create a new pod. So I'm just doing kubectl delete pod, and then pass in the ID. Now the pod is deleted, but now another one is created right away, so, and with a different ID. You didn't really see this, but if you see here, it says container creating. So replica set basically looked at that and said, when I deleted it, it said, okay, I need to create a new one. It does that right away. It's very quick. All right, so that's the replication. And then, so you have your pods running. You have your replica set watching your pods. So you don't have to watch them yourself. You just let the replica set do that for you. Now you need to expose your pods to the outside world. So that's when services come in. In services, what you do is you create a service with a label selector. So we are using the labels again. In this case, I'm saying the label is FE. And then it will basically load balance all the pods with that label. So it gives you a stable virtual IP for the clients to talk to, and then when the clients will talk to service, and then service will proxy that request to the pods. So let me just show you that quickly again. So here I am. I have kubectl get deployment. I have my deployment running, and I have my pods running as well. What I'm going to do is I'm going to say kubectl expose deployment, give my deployment ID, and then type equals load balancer. So what I'm saying basically is that expose my deployment and put a load balancer in front. So expose my pods to the outside world. That's how you say that in Kubernetes. So what this will do is it says services expose. So if I do kubectl get service, you can see that I have my service. It has an internal IP, but the external IP is pending because Google Cloud has to create a load balancer and attach that load balancer to the Kubernetes cluster. So that will take a little bit of time to happen. But once you have your external IP, you can basically get to your pods from outside world. So let me just go fast forward this a little bit. All right, so yeah, as you can see, I do kubectl get service. I have the IP now. So that means I have my load balancer. And if I go to my browser and enter that IP with port 8080, you're going to see the same app again, nothing exciting. But this time, it's running in Google Cloud in a Kubernetes cluster and exposed behind a load balancer. So let's see that happening. Yeah. So yeah, that's what it takes to expose an application. All right, let's see how much time I have. All right, I have a couple of minutes, so I'm just going to go quickly. So scaling. Let's say you have 3 pods that are managed by ReplicaSet, and then there's a service that exposes them to the outside world. If you want to have more pods, what do? You just go to ReplicaSet and change it to 4, and that's it. Like, that's what scaling is in Kubernetes. It's just basically changing one configuration somewhere, and it just scales for you. I have a demo on scaling, but I'm not sure I have time to show it. I'll skip that. And the rolling updates. So let's say you have pods managed by ReplicaSet, and then you have a service. You want to update this pod from version 1 to version 2. How do you do that usually? The right way of doing that is like this. So what you would need to do is you would create a replica set with the new version, and then you would create a pod and attach that to the service, and then you will take one of these out, and then you will increase that to 2, take one out, increase that to 3, and take one out, and then once everything is running, you want to get rid of the replica set so you have your app only running version 2, right? So that's a lot of work that you need to do, but Kubernetes does this automatically for you, basically. So you don't have to do this yourself. It basically, by just with one command, you just run that command, and it will do this rolling update for you automatically. So let me just show you the rolling update quickly. So here I am. What I'm going to do is I'm going to edit my code and change something small in my application and do a rolling update. So what I'm doing is I'm just going to change this code that says learn how to build ASP.NET apps. I changed it to that can run on Google Cloud. That used to say that can run anywhere. I changed it to Google Cloud. So what you need to do first is you need to actually publish your application again because the code changed. And then you need to rebuild your Docker image. You need to push that image, and then once you have your image in Google Cloud, you can just tell Kubernetes use this image. So let me just do this quickly because I'm running out of time. So what we are doing here is we are building a new image with the change, and then once the image is built, if you look at the images, you see that a new version is created, version 2. And then I need to push this image to Google Cloud, right? So I use gcloud docker push, so I'm going to push this image to Google Cloud. So I'll just fast forward that because we don't have time. And then now I have my image in the cloud. So to do a rolling update, all I need to do is kubectl edit deployment hello.net. So this basically gives me the config file for my deployment. And all I need to do is just go down, and there's a section for the image. So this image right now is pointing to version 1. I just need to change this to version 2. And by changing it and saving the file, the rolling update that I show you, it basically happens automatically behind the covers in the right way. And if there's something wrong with your version 2 and something goes wrong, it will actually stop the deployment and go back to version 1. So all the stuff that you need to do yourself, that is been done for you by Kubernetes. And if I refresh my application, we should see the update, is right here, okay? All right, I should wrap up now. All right, and then lastly, you can do Canary deployments. So if you have a replica set with version 1, you can create another replica set with version 2, and you can put everything behind the same load balancer. This way you can have the same 2 versions of your application running in the cloud, and you can test version 2 before you can update. So you can do Canary deployments. And there's also auto-scaling, but I'll have to skip this. Basically, you just deploy something called Heapster that looks at your CPU, and then you can say to replica set, oh, if my CPU target is more than 50%, make sure that you scale up. So it will do that for you automatically. And then there are DaemonSets. I won't get into because we don't have time, but find me afterwards if you want. There are jobs. These are pods that get run until completion. It's good for batch processing. There are StatefulSets for stateful applications like databases, stuff like that. And there are config maps for your configuration that gets attached to your pod as volumes. There are secrets where you have secrets that gets attached to your pods as volumes. I'm going real quickly because I don't have time. And there's even more. So I just show you the basics, but there's a lot more. If you go to kubernetes.io, you can read all about this. If you have any questions, my Twitter, my email. And if you have any feedback about my talk, please send me here, okay? Thanks very much.